In this example, I'm going to try to demonstrate the quantile plots or QQplots, or sometimes called normal plot. This is going to be on your page 208 of your textbook. I've got 49 observations, more than theirs, but it's the same principle. So X has got all these values. I've actually taken X randomly from a normally distributed population. So this is a sample from a normally distributed population. Let's see how we go about to do our quantile plots. So the first thing is I'm going to click on the column A, Control C, that copies it, and bring it over to column F, for instance. Control V as in Victor. I've got now that in my column F. I've got the original, I've got this one. Now I'm going to sort this. We've been sorted before, but you can click on the whole column, go to data, A to Z, that's an ascending order sorted data. Now I'm going to rank them. To do the rank, and which also counts it for you, enter 1 and 2. Now I've given a pattern, double click in the corner, it'll count it, and as I mentioned, I've got 49, so let's go check, make sure, yes I do. To continue with quantile plot, I calculate the probability, and the probability to calculate that, I'm going to take first rank number, first rank divided by 49 plus 1, which is 50. If you don't do plus 1, it's not a capital crime, but it's going to give you some strange result at the tail end of your data. Double click, everything is computed. Now we go look at the standard normal values for those probabilities. And to get that, I say norm S inverse, if I give the probability, it'll give me the Z value on the standard normal distribution. There, I got it. Should be negative, and it is. Double click, all of them are computed. Now, to do my plot, I want to put the Z on my x-axis, X on my y-axis. So I'm going to again take my sorted column, Control C, bring it over, Control V. Now I'm going to highlight the two, Control Shift down, highlights the two. And I'm going to say insert. I'm going to insert one of these graphs. So say this. If my sample observations fit normal density function, this should be a fairly straight line. And it is close to straight line, but it's not exactly straight. Usually samples are expected to deviate. Let's put a straight line on it. Right click on one of these diamonds and say add a trend line, and the default is a straight line, but also get the equation by checking the display equation on chart. Close. Let's take this equation, put it on the side. Your intercept of this line should be close to the mean. So my mean should be close to 78.88, not exactly, but close, 78.88. And your slope, which is 10.32, okay, should be the standard deviation, which we've seen. So the standard deviation should be close to that. Fits straight line pretty well. And the reason I know that should be close to the mean and that close to standard deviation is that this equation is related to the finding the standard value. Standardizing, defining the standard normal, which is x minus expected value of x or mu or x bar divided by standard deviation. Basically that equation is something like this. So if these points were really taken from a normally distributed population, it should fit the straight line pretty well. It's off a little bit, but pretty good. Generally, they look much worse than that. Now I'm going to calculate the mean. To calculate the mean of the sample, I'm going to say equals average. That's a quick and dirty way of getting the mean. And click on that, Control Shift down, and that should give me my average of the population that the sample came from. Pretty close, very close. And let's calculate the standard deviation. I'm going to say standard. As soon as I say that, it says standard dev. I use this one. There's several of them, sample, population, whatnot. I'm going to use that. And I'm going to click on that, Control Shift down again, and that gives me the standard deviation. Very close again, 9.97, 10.32. Mean was right on the button. Standard deviation off a little bit, and there is your QQ plot. We've got it.